Very good. Your resistance has something to do with it. So just like on that last unit, you guys got a sheet of notes. You get a sheet of notes on this unit right here. And if you notice, if you turn to your very last page, this is your sheet of notes. And if you'd like to step up to the challenge, you're more than willing to do so. The challenge would be to go on to the test with all these memorized, as opposed to having to use the sheet of notes. If you don't want to do that, then obviously I suppose you can just use the sheet. But yeah, every once in a while somebody says, you know what, I'm gonna try to memorize them. So it's up to you. As we look at this sheet, have you guys seen this before? Yep, that is definitely not new. Have we talked about law of sines? How about law of cosines? Area of triangle? Do you remember sine squared plus cosine squared is equal to 1? So these are all ones that you've actually seen before. In fact, conversion between degrees of radians, area of sector, arc length, these are all formulas that you've used. This is not a bad thing to take with you into calculus class or off to college. Okay, it's a nice organized piece. It's not like I print this off of a, some website or a book. This is something I spent time creating and putting together for your benefit. So you might want to hold on to that guy. It is a useful piece of information. And so let's start with our first set of new formulas. So we've covered probably about a third of those formulas. Let's make up some new ones, okay? And we start with even and odd identities. From first semester, we talked about even and odd functions. I don't know if you really remember what this was, but we said a function was even if, when we plugged in negative x to a function, it came out to be just f of x. And we said it was odd if f of negative x was equal to negative f of x. You kind of remember doing a little bit of that. It was a very short period, but you plugged in a negative and you see what you got out. So it turns out that sometimes you could just look at a function. For example, y is equal to x to the fourth minus x squared. Somebody want to guess whether or not that's even or odd? It is even. And so, but it's tough to tell whether the trig functions are even or odd. And so what we can do is we can look at the graph, and that can give us an indication. And so I'm first going to graph sine of x. And sine of x looks like this. Everybody good with the sine graph? Okay. So the question is it even or odd? If it's even, it's symmetrical about the y-axis. Meaning you can flip it around the y-axis, you get the same thing. It's odd if you can flip it 180 degrees and get the same thing. So, but what I want to do is I want to use this definition here, okay? So I'm going to plug in an x value. So suppose you plugged in an x value right there. Would you get out a positive or a negative value? A positive. Suppose I plugged in the same x value, but just negative on the other side. If you plugged in a negative x, would it come out positive or negative? Negative. So that shows us that, in fact, this is an odd function. And notice what happens with odd functions. When you have f of negative x, it comes out as negative f of x. And that tells us this, that sine of negative theta is negative sine of theta. We didn't factor out the negative. We didn't divide by a negative. It's simply that according to even and odd properties of functions, the negative moves to the front. Same is true for cosecant. Now, what does the graph of cosine look like compared to the graph of sine? Very good. So we remember things about previous units. You guys are really smart. Good job. Everybody okay with a rough sketch of my cosine graph? We're going cosine of x here. So if I were to plug in an x value right here, do you get out a positive or negative? And if I plugged in that same x value on the other side, but I plugged in a negative, what would you get? Yeah, you get the same thing, don't you? So it turns out that this is even. This is a even function because f of negative x just produces f of x. So cosine is an even function. And what that means for us is cosine of a negative theta is simply cosine of theta. And secant of negative theta is secant of theta. The last one would be the tangent function, tangent of x. And I'm going to just have you look at the graph. Just by looking at the graph, do you think that that's an even function or an odd function? It is definitely an odd function. And so the properties will be this. Tangent of negative theta becomes negative tangent of theta. And cotangent of negative theta becomes negative cotangent of theta. Okay, so let's try a couple examples right now. Our objective today is to, oh, and by the way, as we look at our very last page right here, notice what we have just done. We just went over even and odd identities. They're covered. They're all right there. Boom, let's go. Our goal for the day is to be able to simplify trigonometric expressions. There are many methods to simplifying. We are going to give you the first and most basic method, and that is this, to turn everything in terms of sine and cosine. So sine times secant can be simplified. And to do that, I'm going to write it as sine of theta over 1 times, does anybody know what secant is and how it's related to sine or cosine? Good, 1 over cosine. And if I multiply those, I get sine of theta over cosine of theta. And hopefully that will tell me something. Anybody know what sine divided by cosine is? It is tangent. And so this expression simplifies to tangent of theta. Now, if you're having trouble remembering some of these pieces, what I'd like you to do is I'd like you to look at this very last sheet. Notice how we have tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is cosine over sine. But please do not get that confused with what's over here. Notice tangent is 1 over cotangent. But we won't be using that right now because our goal is to write things in terms of sine and cosine. See how related these pieces are to sine and cosine? That's a good thing. So we're going to use that. So if you need those, again, that's something that you'll be able to see. Let's continue to work. Cotangent times sine. How can I rewrite cotangent? 1 over tangent, but I want to rewrite it in terms of sine and cosine. Very good. Cosine over sine. Yep. Tangent is sine over cosine. Cotangent is cosine over sine. Times sine of theta over 1. What happens? They cancel and leave you with cosine. That's kind of cool. We're going to skip letter C. We're going to move on to letter F. Cotangent times secant. How do I rewrite cotangent? Cosine of theta over sine of theta. Times. What is secant? 1 over cosine of theta. Notice what happens. Cosine over cosine cancels. 1 over sine. What is 1 over sine? Cosecant. These are baby steps. You won't have a problem like this on the test. It's too easy. This is foundational level. We've got lots of room to grow before we're ready to take on some problems. Please try letter E on your own. Try letter E on your own. This is not the unit you want to procrastinate. Okay. This is the unit that has caused the most number of tears over the years.
I promise not to sue Mr. Garrett for emotional.
Just this one, I rewrote it as sine over cosine times 1 over sine. Sines cancel, and you get 1 over cosine. What is 1 over cosine? Secant. Very good. Okay, so now we have secant of negative theta, cosecant negative theta, and cotangent negative theta. We do not leave a negative angle. We do not leave a negative angle. So what can I do with this negative angle right there? No. Thank you. This is just secant of theta. Notice from what we just talked about right here, secant, the negative just disappears. Same with cosine. What happens to the negative for cosecant? It moves out front. Thank you, Miss Avery. And then what happens to the negative for cotangent? Moves out front. So will my end result be positive or negative? Because the negatives will cancel. So good, I've dealt with the negatives. Now let's deal with the rest. Secant is 1 over cosine of theta times what? 1 over sine of theta, thank you, times, no, cosine of theta over sine of theta. Good. What's going to happen? The cosines do cancel, and so what do you think is sine times sine? Sine squared. So you can see in this situation I get 1 over sine squared. Cosecant squared. Very good. Cosecant squared of theta. One over sine is cosecant, so 1 over sine squared is cosecant squared. Okay, tangent of negative theta over over secant of negative theta. What's going to happen with the negative here? Negative tangent of theta over secant of theta. Good. So I've dealt with the negative. Now, how do I rewrite negative tangent? Negative sine of theta over cosine of theta. Divided by? Divided by 1 over cosine. Or you can multiply by the reciprocal. When you multiply by the reciprocal, what will you be left with? Negative sine of theta. Please try letter H on your own right now. Please try letter H. Tangent, negative moves out front. Secant, negative goes away. I have secant of theta. Anybody else? We okay? All right. A couple more before we move to a little bit more difficult problems. Sine times secant over tangent. I'm going to show you something that I like to use when I do this. Sine of theta over 1 times 1 over cosine of theta. And it's important that you don't become robots during this time. Robots just kind of follow one pattern. They just stay in the holding pattern. They don't ever think outside the box. But I didn't change the bottom. And the reason why is that I don't really need to because I noticed something right away. What are you going to get in the top? You get sine over cosine, which is tangent. So what's tangent divided by tangent? 1. So, you know, if I was grading your test, for me at that point, that would be enough for me to see what your intentions are. I'd like to see things, you know, most of the way through for these so I can follow your work. But that's you know, you can see how that works out. We're going to skip this one, but we're going to move on to this guy right here. Notice how I have a squared. No different. You just write sine squared of theta over 1 times what? Good. Times
1 over sine.
Good. And so in this situation, you can see that Yeah, you can see that the signs are going to cancel out, and you get cosine of theta. Now, this very last one before we go to the next side, this is straight from an ACT question. You guys could see it prior to this class. You wouldn't really know what to do, would you?
No.
And so we're going to make this really easy. Notice how tangent of x is just tangent of x. But what happens to cosine of negative x? Just cosine of x, right? And it looks like magic, but we know that property is true from our even and identity stuff that we just talked about. So, and then what happens to tangent of negative x? Yeah, so what are you going to get? Yeah, the tangents cancel, you just get cosine of x. And so you can see how that's really not a very difficult problem as long as you remember those properties. So, all right, time to get to the types of problems that you're going to start to see on your test. Okay, you have the foundation. Okay, you have the foundation. 1 minus cosine squared times cosecant. Okay, so what's different about this problem? Yeah, anybody tempted to distribute right now? And we don't want to do that. What we want to draw our attention to is this thing right here. Notice how we have a 1 and a squared. And that's going to come in really handy for us because you have this nice sheet of notes and you're going to start using that now. And notice how here I have a 1 and I have a cosine squared as well, correct? Remember, what we just saw was this expression. We saw 1 minus cosine squared of theta. That's what we saw on our sheet, didn't we, that we're trying to solve? Well, look at what happens here if I subtract a cosine squared over. Minus cosine squared of x minus cosine squared of x. What remains on the left-hand side? Sine squared of x is equal to 1 minus cosine squared of x. So you learned that the most important fundamental theorem in all of trigonometry, other than the Pythagorean theorem, is this guy. Sine squared plus cosine squared is 1. But we can manipulate this by adding and subtracting things around. Look, we have a second formula. We would have another formula as well. Cosine squared is equal to 1 minus sine squared. And look at what I've done. I've actually taken them and I've written them out for you over on this side. Not every single option, but I have written a few for you. And here's something else that's cool. We're not going to use it right today, but maybe you noticed. Isn't 1 minus sine squared, isn't that the difference of two squares? And can't the difference of two squares factor? So there's a ton of relationships that exist within trigonometry. And for me, that's when math started to become interesting, is when I saw all those connections. So we're going to hang on to that, and we're going to use that right here. So let's check it out. We go back to this spot. We are not going to distribute. We are going to recognize that 1 minus cosine squared is what? Sine squared. So you have sine squared of theta times cosecant of theta. Now it becomes a problem just like what we did on the front side, correct? So I have sine squared of theta over 1 times what? 1 over sine of theta. What's going to happen? One of the signs will cancel, leaving you with sine of theta. Just say broad shoulders. Okay, let's move to letter N. We got a little bit more to go. You guys are doing well. We're almost to that spot. We got a couple more problems. We're not going to get down to this next section, but notice what I have here. I have a secant squared and I have a 1. And did we have a formula that involved 1 and secant squared? Yeah, something involved tangent, right? If you look at this sheet, sure enough, 1 plus tangent squared is secant squared. So we can use that. Notice if you subtracted the 1 to both sides, you would get secant squared minus 1 is equal to tangent squared. If you can see, I have that written out for you right there. See that? We took that formula, which you got to know a while ago, and we manipulated it. Okay? And so there I go. I'm going to substitute that in. I've got cosine squared of theta times what? Tangent squared of theta. So I will rewrite that as cosine squared of theta over 1 times what? Sine squared over cosine squared. And what are we going to get? Sine squared of theta. What's secant squared minus 1? Just did it. So now you have tangent squared of theta over sine squared of theta. Once again, we make a basic substitution. Once we make the basic substitution, we can then treat it like a problem that we just saw on the front side. Not quite. Sine squared over cosine squared.
Is equal to times sine squared over, no, times 1 over sine squared.
Yeah, so times 1 over sine squared, we multiply by the reciprocal, and what happens?
Cross it out, so you get 1 over secant squared theta.
1 over cosine squared is secant squared. All right, so this next one that we want to do here, this proves to be a problem for people. We've actually covered 2 options at this time. The first thing that we did was we rewrote in terms of sine and cosine, right? And the second thing that we did was we substituted things in, right? The third option that we're going to do is we are going to factor, okay? Yeah, so this is the common mistake. So we're going to do a little bit of... So let's give this a shot. What is the common factor between these 2 terms?
Tangent. Sine.
Okay, our minds are all over the place. See, watch and see if you can tell me now. Suppose this was written as x squared minus x squared y squared. What would you factor out of that? Everybody see you factor out x squared? So what do you factor out of this? Tangent squared of theta. And when you factor that out, think of how you'd factor this. What's going to be left?
1 minus sine squared.
Great, so we factored it.
Oh my god, that's
Now I need what's 1 minus sine squared?
tangent.
Cosine squared. So I got tangent squared times cosine squared. Can I simplify tangent squared times cosine squared? And I get sine squared of theta over cosine squared of theta times cosine squared of theta over 1. Sine squared.
You get the answer.
Yes, you are right. In this situation, you would get that. Now, on the test, if you did this, if you cross those off and did that, I would give you 0 out of 3 points.
That should be 1. You get the right answer.
Nope, tough luck. No.
You were like, this is what I...
Okay, all right. I'm with you. I give you 1/2 out of 3 points. That's what I'll give you. Yep. I am open. I'm open to discussion on this. So if you can get another math teacher to corroborate your ideas, that I should be giving you like. If you were to explain it then to me in that moment, I would award you some points back. If you want all the credit, do it on the test. Remember, I think I'm being reasonable as a teacher saying, show me you know what you're doing on this test. I think that that's a reasonable expectation. Question, sir? Shh. So I got 1 minus sine squared from this. If you factor out a tangent squared from these 2 expressions, you're left with 1 and sine squared. if you were to factor this, Easton, x squared minus x squared y squared, if you were to factor out an x squared, you would get 1 minus y squared, correct? See it now? Very good. Okay, we are done for the day, but what I want you to do is I want you to turn in your homework. First of all, I gave you another sheet in case you want to tear one off and use it, okay? But as you look in your homework, you do not yet know how to do all of these problems. But you do know how to do a few of them. And so you might want to look through and see, are you able to do a few of them and get started, okay? This is my last warning. This is not the unit that you want to procrastinate on. This is not the unit you want to get behind on. This is the #1 retake unit. This is the #1 I see tears in your eyes unit. Have a good weekend.